everyone. Today we have Chloe, who is a top receiver for her ultimate team. They're playing an important tournament, and the game has come down to the final play. Chloe must catch the disc if she wants to give her team a chance to win in the championships. She knows that her throwers are very reliable and always throw the disc with the same velocity, but in order to be certain that she will catch the disc, she will need to solve for how fast she needs to run. To catch it, she wants to be able to run at a speed which is close to the Frisbee. So in order to solve for what speed Chloe will be going, we need to utilize kinematics. And this concept takes two separate things, in our case the disc and Chloe, and relates to certain aspects about them such as position, velocity, or acceleration. So in the first row we have our relative movements towards each other. So this is relating Chloe's position to the disc position, and the same goes for velocity and acceleration. In our second row, there's only something filled in for velocity and acceleration because they can be derived from position equations. So velocity is the change in distance over time, and acceleration would be the change in velocity over time. These equations down here only work if you have a constant acceleration, so that has to be either given in the problem or can be due to gravity during free fall, because we know that it will always be constant.
The actual physics of how a Frisbee works is somewhat complex, and we won't be covering it fully at this time. For an extremely simplified explanation, a Frisbee is propelled forwards by forces applied by the thrower, giving it both translational velocity and angular velocity. Once it leaves the ground, however, it moves upwards by a principle not covered in this class, Bernoulli's principle. Basically, as the Frisbee moves, the air passing over it is forced to flow upwards and over the disc, and this covers a larger distance than the air passing underneath. Therefore, the air above flows at a higher velocity, and since fluids flowing at higher velocities create lower pressures, there's a lower pressure above the disc, which makes it rise. Eventually, though, air resistance slows the disc down, and gravity becomes larger than the upwards forces, and the disc falls back down.
In our first situation, the disc is thrown with a velocity of 10 meters per second, but at the same time, Chloe is not starting from rest but has a constant non-zero velocity. We know that the thrower is 25 meters away from the end zone, and Chloe is starting from 15 meters away from the end zone. So we're trying to find how fast Chloe needs to go if she wants to catch the disc in the end zone. In order to solve this, we are going to use our simple velocity equations, knowing that velocity equals the change in distance over the change in time. Since we know that the disc is already going 10 meters per second, we can set that equal to the distance that the disc needs to go, which is 25 meters, and solve for time. The total time that the disc will take to get to the end zone is 2.5 seconds. Knowing this, we can then use it to solve for Chloe's velocity. So we know that Chloe has to go 15 meters, and she has to cover this ground in 2.5 seconds. Solving that, we get that Chloe needs to go a total of 6 meters per second in order to catch the disc in the end zone. Now let's see if she can actually do that.
Yeah!
Now we will use a different situation where Chloe is starting from rest. So again, the velocity of the disc is 10 meters per second, and the distance from the end zone that Chloe is 15 meters. But now, since she is starting from rest, we have to solve for the acceleration that Chloe needs to catch the disc in the end zone. So we are going to start off using our relative velocity equation. If we know that Chloe is going to catch the disc, this means that the relative velocity between each other has to be 0. Knowing this, and knowing that the velocity of the disc is 10 meters per second, we can then solve that the final velocity of Chloe must be also 10 meters per second. Now we can use one of our basic kinematics equations, knowing that her acceleration will be constant. We plug in her final velocity, which must be 10, and the distance she has to cover, which is 15 meters, and then we can solve down for acceleration, which must be 3.33 meters per second squared. Now let's see if Chloe can actually achieve this acceleration.
What? Why?